How's it going, Rams? Welcome to 11.4. We're going to be talking about how to find the areas of kites and related figures. The related figures specifically being a rhombus. Let's go. Area of all kites, including all rhombi. And I'll show you how we find this in class, but for now the equation is area equals 1/2 times the entire diagonal 1 multiplied by the entire diagonal 2. Now let's take a look here for a second at the rhombi. What do we know about it? Well, it's a square, meaning the sides are all even, but no other property of a square does it share, so all the sides are even. We also know that diagonals are bisected, so we have equal lengths here. And we also know that angles are congruent here. These are bisected and same as these over here. And we have 4 identical triangles. We'll learn more about it too. Okay, example 1. The area of a rhombus is 120 square centimeters. And so we know area is 1/2 times the length of diagonal 1 times the length of diagonal 2. And it's saying that this is equal to 120. And the shorter diagonal is 10. Underline, find the perimeter. And this here tells me that I need to find the length of all the sides. Now it's a rhombus, so all 4 sides are equal. Let's draw this in now. Here's my rhombus. It's asking me to find the perimeter, and it's telling me that I've got a diagonal here and a diagonal here. And if I multiply both of them and divide by 2, I get 120. Now to find the perimeter, I need to find a side. In other words, I need to find a side. And I'll multiply it by 4 to get the perimeter. Now the only information they give me is that the shorter diagonal is 10. And because they're bisected, I'm going to write 5 here and 5 here. Okay. So far, that's all I know. I also know, though, that I've got right angles that are created here by my diagonals. The diagonals are perpendicular to each other. So let's separate one. Let's take this triangle over here. And I know this is 5. This here is my red side that I'm looking for the length. And I have my right angle. Okay. Let's go back to what I was given. I was given that the area equals 1/2 diagonal 1 times diagonal 2, and it's equal to 120. Now I only know one diagonal, and the length is 10. So I'll write this in, 1/2 times 10, one diagonal, and I don't know the other diagonal, but I'm going to be able to find it in just a second, and I'll set it equal to 120. It's what they gave me the area is. Let's solve for the second diagonal. I have 5 times diagonal 1 equals 120 because I simplified over here. And now to solve for diagonal 1, let me divide both sides by 5, and I get diagonal there equals 24. Okay, this entire diagonal equals 24. And since I know the diagonals are bisected, I'm going to have 12 here and 12 there written down, because now I'm going to use that as this side. So I have one diagonal, the half is 12. The other diagonal half is, 12 here and 5 over here. Because I'm looking for my perimeter, let me find this length of my red side. Now let's just use Pythagorean theorem or know special, and I get 13 for this length. Again, it's asking me for the perimeter. So I'm going to write 13 here, 13 here, 13 there, and 13 on my 4th side. So the perimeter equals 4 times 13, and I get 52 centimeters for that. Now backing up from the beginning, I was given one diagonal and I was given the area. The next thing I did was I found my second diagonal using the area of the formula. Once I found my second diagonal, I put into my small triangle over here, and then I found 13 as side length for one side. But I know that all 4 sides are equal. I multiplied it by 4, and I got 52 for the perimeter. Next example, find the area of a rhombus with one angle that measures 120 degrees and a perimeter of 32. Okay, and just as a note, I'm always going to write the area equals 1/2 diagonal 1, diagonal 2, and I know I'm going to have to come up with those two diagonals because I'm looking, the question is the area of a rhombus for us to find. Okay, let's draw this in now. Here's my rhombus. Perimeter is 32. All four sides of a rhombus are equal, so let me divide this by 4, and I'll get 8 is the length for each side. Okay, well, I don't need to know the length of each side per se for the formula. I need to know the length of each diagonal. And the other piece of information I was given is that one angle, and here's the obtuse one, is 120 degrees. Also means this one's 120 degrees. Let's draw in my diagonals that ultimately I'm going to need to find. I'm going to pull out one of the triangles. I'll use this one here. And since all four of them are congruent, I only need one. So it says that 8 is my hypotenuse, because I've got that there. And I have 60-degree angle here because the diagonal is bisecting my 120-degree angle. Yes, sirree, I've got a 30, 60, 90. Now, if this side here equals 2x, and this is x, and this is x root 3, I'm going to get x equals 4. So half of one diagonal is 4. And I'm also going to get that this side is 4 root 3. In other words, this is my 8, my hypotenuse. This here is my 4, and this side here is my 4 root 3. Now I'm going to put 4 over here, the other side of my diagonal, and 4 root 3 over here, the other part of my diagonal. So diagonal 1 is going to be 4 plus 4, which equals 8. Diagonal 2 is going to be 4 root 3 plus 4 root 3, which gives me 8 root 3. I'm going to plug in those two pieces of information into my area formula right here. And I'm going to get area equals 1/2 diagonal 1 times diagonal 2. That has to be a root 3, excuse me. And now I'm going to get 4 times 8 times root 3. And now I'm going to get 32 root 3. And since it's area, it's going to be feet squared. Now let's recap on this again. I was given that I have a 120-degree angle and a perimeter of 32. And with the perimeter of 32, I divided it by 4, and I got 8 for the length of each side. And because one of the angles is 120 degrees, and it bisects, the diagonal bisects that angle, I came up with my 30, 60, 90 triangle with a hypotenuse of 8, which gives me the base is 4, and the other long leg is 4 root 3. Now one diagonal's half is 4, therefore the whole diagonal is 8, and the other's whole diagonal is 8 root 3. I plugged it into my formula, and I got 32 root 3. Alright, example 3, find the area of the kite below. Now the kite is a little different than a rhombus, and we'll go over their properties more in class. But you could see what I have marked here that a kite has. A kite has these two short sides congruent and the two longer sides congruent also. I also know that I have one of them, one of the diagonals is bisected. The other one clearly is not, and they're also perpendicular to each other, all of them. So the area is the same formula. Area equals 1/2 times diagonal 1 and diagonal 2. And here I'm given one of the diagonals. If this is 8, I know my other one is 8 also. So one of the diagonals is 16. So let me write that in. 1/2 times 16, and I need one more diagonal. Let's figure this one out. all by Pythagorean theorem. Let's call this side x, this part of the diagonal y, and let me use the Pythagorean theorem here. I'd have x squared plus 8 squared equals 100. And I could solve for x, or I could notice that this is one of those special triangles. It's a 3, 4, 5. In this case, x then would be 6. So you could solve using Pythagorean theorem, or you could recognize this as the 6, 8, 10, which is a multiple of the 3, 4, 5. So this length here is 6. Now I can't say that y equals 6 because it's not a rhombus. Y is its own independent length, and let's find that using the same method of the Pythagorean theorem. And let's set this one up as 17 squared equals 8 squared plus y squared. And we get 289 equals 64 plus y squared. Subtract 64 from both sides and I get 225 equals y squared. Take the square root of each side and y now equals 15. Here I've got 15. Therefore my entire diagonal is going to be 15 plus 6 and I'll get 21. So I'm going to write in a 21 up top here. So this is going to be 8 times 21. And if I simplify that, I get 168 units squared is the area of this kite. Last one, find the area of this kite over here. Now, I'm not quite sure, but I'll ask y'all in class if you guys have learned properties of similar triangles in this book. I know in our previous book in geometry over in California we called this side x here. Now, the reason why I'm calling that x is because I know the area formula is 1/2 diagonal 1 times diagonal 2. And I have 1/2. One diagonal is 3 plus 27. So what I'm going to write in for that then is 30. And I have to find my other diagonal. They'll both be x. Now, what we did in California is we wrote up a proportion for similar triangles, and it would look like x equals 3 equals 27 over x. We simplified and we got x squared equals 81 and x equals 9. So I have 9 and I have 9. And therefore my diagonal is 18. And once we reduce this, we get 270 units squared. Alrighty kiddos, next slide is the homework. There we go. I'll see you in class. Thanks.